Welcome to our Azure Incident Retrospective. I'm David Steele.
I'm Sami Kuba. We work in the Azure Communications team.
In addition to providing a written post-incident review after major outages, we also now host these retrospective conversations.
You're about to watch a recording of a live stream where we invited impacted customers through Azure Service Health to join our panel of experts in a live Q&A.
We had a conversation about reliability as a shared responsibility. So this includes our learnings at Microsoft, as well as guidance for customers and partners to be more resilient.
We hope you enjoy the conversation that follows.
Super, and today's incident, we're going to look at virtual machines with v6 trusted launch failing during the initialization phase. This meant for a broad impacted window from the 7th to the 16th of June, there were a subset of virtual machines, both Windows and Linux, across multiple regions that weren't starting up properly.
That's right. So to talk us through the incident and our learnings today, I'd like to introduce a couple of engineering leaders joining us. To our left, we've got David Hepkin, Corporate Vice President and Distinguished Engineer. And on the end, we've got Giri Viswanathan, our Principal Software Engineering Manager, both joining us from our Core OS engineering team within our Cloud and AI engineering division.
Super. Before we get started, David, perhaps we can turn to you. Before we get into the actual incident itself, could you walk us through some of the actors involved? But we're really interested in to understand what trusted launch is, how the vTPM module plays a part, and how does all that kind of interact on a normal day?
Yeah, absolutely. So trusted launch is a key capability that we offer to Azure VMs that enables those VMs to have extra security and monitoring for the VM's startup and ensuring that the boot process of the VMs has not been tampered with. And the way that we enable that in Azure is through sort of two key technologies that Trusted Launch brings. One is Secure Boot, which is a capability provided by the virtual machine BIOS, but basically it is a capability that ensures that the software that we use to boot the virtual machine has all been trusted and authenticated. And then the other key piece is the virtual TPM. And the virtual TPM is a capability that we provide to these virtual machines that will measure, so basically keep track of all of the software that is used to start the virtual machine. And then those measurements, or that log of information of the different software that was used to start the virtual machine, can then be looked at and analyzed to ensure that no bad actor had inserted some malicious software or monitored or tampered with the virtual machine to affect how it boots. And this technology is based on how physical systems have secure boot technology. So basically what we have done is we have modeled this based on if you get a physical system, you have secure boot and a physical TPM module that sits on the silicon on the system. What we've done is taken that and brought it to virtual machines, and we leverage software to implement those things, whereas on a physical system you might have actual physical chips doing those things.
Got it. That's great. So now we understand that the different pieces involved here. So I want to start from the perspective of customer impact. So let's fast forward to that fateful day on the 7th of June here. What did this feel like for customers when it started to happening? Now, the PIR mentioned that VMs were failing to start up. Did some fail to reboot? Did the VMs reboot on their own? I just want to understand kind of from this perspective, was it intermittent? We said 7th to the 16th of June. 9 days is a long time. Like, this was some customers, some of the time. Help us to understand that pain.
Yes. So absolutely. So in this particular case, what you would have seen as a customer is that most likely when you go to restart your virtual machine that has this trusted launch capability, the virtual machine would not restart. And so the primary impact was at the time that you restarted, and it could have been because perhaps the virtual machine was taking an update, right? And it was just rebooting because the software in the virtual machine was rebooting. But at some point during that period, if you went to reboot your virtual machine, it may not boot up. And then even if you tried to deallocate and reallocate the virtual machine, redeploy it, you would continue to see this problem. It was persistent to the virtual machine because of this issue. And so during this period, while not all virtual machines were impacted, it was a relatively small percentage. Those virtual machines that were impacted, it was a persistent impact.
Right, they were hard down until we took the workaround, which we'll get to.
That's
and
right.
Gary, David mentioned here that unless customers were rebooting, there was a reason that a lot of customers were rebooting around this time.
Well, we found out that this spike that we saw correlated well with the Patch Tuesday rollout of Windows, and that would of course naturally cause these VMs to boot up. And the issue starts happening when the VMs boot up. And then once they get into the state, then they stay in that state, and it doesn't boot into the main OS.
Got it. So lots of reboots.
Yeah, and it's in the scale at which Azure talks about. I know small percentages can mean still very, very big numbers for customers. But we go, the cloud is complex, and complex systems fail in complex ways, and we know that there's no singular root cause. But when we speak about the trigger events, you mentioned Patch Tuesday, and in the PIR we mentioned a bug that was exposed as part of a deployment. Were there certain, I'm interested to know about that, and why was some virtual machines over others? Were there certain factors that had to line up for customers to be impacted?
The main triggering event for this was basically VTPM, persistent state, getting into an inconsistent state. Right? And that was caused by basically two bugs. One was when the VTPM persistent state, VTPM does all these measurements, it stores keys and certificates, those gets persisted on the disk, and when the VM comes back, those persistent state gets pulled back in, right? When the VTPM state gets exhausted, it has a certain limit, and once it gets exhausted, it could get into an inconsistent state. That was the main triggering event that caused this problem. Now, there were two specific bugs that caused this. One was the bug that gets into the state, into the inconsistent state. Another was a contributing factor that will increase the size of the TPM, one of the objects in the TPM, and that would exacerbate the issue and force this situation on the. That was part of this deployment, and that's what caused this incident.
Got it. I'd love to understand a little more about the deployment itself. We talk a lot during these sessions about safe deployment and kind of rolling things out slowly, things kind of doubling over time, starting in one region. The fact that this was multi-region makes it sound like we had some misses from safe deployment. Was this able to sneak under the radar?
Yeah, so that's the most interesting part. Like David mentioned, this particular problem was dormant, right? It wasn't like you deploy and immediately see the problem. In this particular case, we started deploying on like 20th of May, right? And the first CRI we got was on 9th of June.
That's a customer noticing and contacting support.
That's a customer noticing and contacting it. Basically, it depended on the TPM's past history, how much operations has happened on this TPM, or the operations that are happening after taking this update, right? And also rebooting back to the state where this would take effect, right? That's where it will get into this bad state. So it wasn't. That was the interesting problem in here, that we couldn't figure out the problem immediately after deployment. It took quite a lot of time to get to this.
That's why it was able to roll out to multiple regions, because it hadn't caused pain yet.
Yes.
Okay.
Yeah.
But once we kind of understood this happened, what steps do we take? I know there were multiple mitigation strategies. It took a number of days, even once we found out. Could you walk us through some of the things that we had to do to mitigate quite a complex scenario?
Yeah, so the CRI came in on 9th. We immediately engaged. We pulled in the right SMEs into the thing, and we started investigating this problem. There was not an immediate root cause to the or immediate issue to the deployment itself, right? So we had to work out that situation to figure out this was caused by that specific deployment that started on 5/20th. By 10th, we stopped the deployment out of safety, and then we could figure out the first triggering event, and we were like, okay, let's build a mitigation for that. We started rolling out that mitigation around 10th and 11th, right? And we were expecting the numbers to start going down after that. And come 12th, we still see new CRIs. The thing started creeping up more. So we were like, okay, there must be some other triggering event. So we started looking more, we started investigating more. And that's when we identified the second issue, and then we built the mitigation around that. Around the same time, by 12th, it was a Sev1 incident. We had declared the outage. We knew that it had reached around 14 regions. Glad we stopped it at 14 regions and we didn't go beyond that. And then there was a Sev1 bridge. We followed the Sev1 playbook, right? David was driving the main bridge. There were multiple work streams created, and we were one work stream for identifying the mitigations that we can mitigate things quickly. Second work stream was around building up validations, because we figured out that we're going to have to roll out multiple mitigations here, right? And we started prepping the validation paths so that we have manual validation as well as automated validation to get enough confidence. And then we had the monitoring work stream, where we started looking at, how do we monitor these mitigations? Are they taking effect? Are they causing a problem? The last thing we wanted was triggering another problem because of the mitigations that we created. So all those was going on, and by 12th, we figured out that disabling VTPM was a good mitigation that we can roll out. So we started communicating that with the customers.
And now that was initially communicated as this is something that you as the customer, if you are impacted, you could choose to implement yourself as a workaround?
That's right. So initially we communicated that to the customer that they can take the effect, and we gave the steps to take for the customer. And in parallel, we also had the work stream to automate this thing so that we can mitigate it for the customers, for the TPM, for the VM to at least start booting up. Right?
Got it. And that's not mitigating the incident broadly, that's mitigating for the specific VM that's run into the issue.
Yes.
And that's by us disabling the
That was-
VTPMs.
that was
Now,
us.
when I read that in the PIR, I thought, can that be right, that we went in and disabled these? I know, David, you mentioned a little bit that there aren't security risks to that. Could you help us understand us disabling the VTPM? Sounds like a big deal.
Yeah, so as Gary was saying, we certainly were pursuing, rolling out a mitigation that addressed the underlying, software issue that we had as quickly as we possibly could. And he was describing those work streams that we were going. But, we recognize in order to be safe, anytime we do a deployment, it takes some time to make sure that we have a fix. And so that has been fully validated. And so we recognize that the fastest way to provide relief to customers that were seeing this issue was to just go and change the configuration of the VM to disable the VTPM. And so that's why, as we discussed, we initially provided communication that customers could take that action on their own, but we recognize that still requires manual action for a customer. And we saw that even after sending those communications, there were still a number of VMs that were hitting this issue. And once a VM hit this issue, we could tell through our telemetry that it was consistently hitting this issue, right? Because what would happen is every time it would try to boot up, it would hit this problem, and then try again, and it would get sort of stuck into this loop. And so when we looked at those and we saw that that number was not decreasing, and we recognized that we could identify all of those virtual machines, we made the decision we could go and mitigate those ourselves to at least bring some relief to get those VMs back up and running, because in their current state they were not able to do anything.
One of the things I'm curious about, we mentioned as well, if the customer relied on attestation for the VM to continue, they still would have been in problem if the VTPM was disabled?
Yeah, that's right. So going back to David's question about, what is the security implications of us going off and disabling the VTPM? The primary usage of VTPM in Azure for trusted launch is, as I was mentioning earlier, what we call sort of measuring the boot sequence, but basically keeping a log of those things that happen during boot, so that you can verify that the VM booted up just as you would expect. And there are other services you can leverage that take that information and provide alerting for you and monitoring. And so by disabling the VTPM, we were effectively disabling that monitoring and alerting capability, but we were not disabling the actual secure boot enforcement that enforced that all of the code that we launched for the VM at boot met all the secure boot rules, and for customers that leverage the virtual TPM for what we call attestation purposes, to basically prove that the virtual machine is in a good state in order to perform some function, those services were not compromised; they would basically just be disabled. Right, and so from that perspective, our view is, we were not making the virtual machines any less secure, right? We were getting them up and running. For customers that had a hard dependency on the virtual TPM to perform some operation, those VMs would still, unfortunately, not be fully functional. But for other customers where it was just more for monitoring purposes, they would lose the monitoring, but they would at least have the virtual machine, operational.
Sure. I mean, at least you can have one and not the other,
Yeah.
right? Because in its initial state, you can't do anything, whether
Exactly.
you need the VTPM or not. But once it's disabled, either by customers doing that themselves when we suggested the workaround, or by us doing that later in the incident, customers could still use the VM for anything that doesn't need a VTPM anyway.
That's right. And then one thing to note, since we're on the subject of disabling the VTPM, so we did do this proactively to disable VTPM for customers. We did not, after the incident, go back and re-enable the VTPM. And the reason for that is because in order to enable the VTPM, you have to reboot the virtual machine. And so the last thing we wanted to do for these customers is then introduce another reboot for them. So that's why we did provide communication to customers once the incident was mitigated and we had a software fix, and it was safe to re-enable the VTPM. We did provide that communication to customers, but just for those customers that are tuning in, as a reminder, I would suggest to verify that you have re-enabled VTPM if you depend on it and need it.
Super. If we go to our repair items, I was looking at the repair items, they were fascinating. One of the things that caught my attention was we're going to kind of improve our threshold so we can detect things like this. We spoke about the scale in which we operate. Even though they're small percentages, the numbers can be really large. One of the things I think about lowering thresholds, when we talk to our SME teams, they typically say the default for engineers is to add more and more monitoring, which doesn't always help. If we lower the thresholds, I'm sure we're going to pick this up, but do we pick up a bunch of garbage as well? Is it going to slow us down, or are we going to is our nervous system going to be overstimulated with alerts?
It is true, yes. We will have some false positives in there, right? And then we're building automation and intelligence around it to make sure that we can rule out those false positives. But the primary motivation here is to be able to catch latent issues like this, the dormant issues like this, and be able to map it back to a deployment and being able to stop the deployment automatically, right? So that means we need to start looking at even lower threshold issues. And there are going to be some false positives. I won't rule that out, but I'm fairly certain we'll build enough intelligence over a period of time where we will rule out those false positives and be able to make very clear calls. In the meantime, there are going to be a lot more aggressive usage of hey, we are seeing this signal, please look at it, and then immediately jump on it and make further progress in the meantime.
And just to add a little bit here, since we're getting into more like the repairs and our learnings and the actions we're taking, on this monitoring aspect in particular, certainly one of the things we learned from this is that a lot of our monitoring for deployments is focused on detecting anomalies that happen around the time of the deployment. So within several hours of the deployment, because generally if we go to deployment, that's the impact is felt very immediate. In this particular case, because this issue was largely dormant until you rebooted the VM, there was potentially a long lag between the deployment and the time a customer would see the issue, and that was another problem with our monitoring, right? And so we've recognized that fact, and we are looking at expanding the window by which we can correlate anomalies with the deployment. Now again, that gets into this challenge around the fact that, okay, well, as you expand that window, now you have a higher chance of false positives and those kinds of things. And so what we don't want to have happen, we need to be able to have deployments make progress, and so there's finding that balance. And so as part of expanding this window, we're doing a lot of analysis to look at, okay, what can we do to help better correlate if there are anomalies that they are associated with the deployment, so that we do not be inundated with potential false positives, that kind of thing.
Yeah, that's something that we actually mentioned in the post-incident review that I wanted to understand a bit better, because great that we've got some learnings around detection and noticing this earlier and getting on-call engineers to take a look. But when it comes to investigating it and understanding what's happening, we mentioned these new capabilities to correlate crash dumps with VM-specific queries. That's trying to get the engineers who are looking at this better information about what's happening? I'd love to understand that better. Gary?
We do get crash dumps when these things happen, right? And we do get deployment monitoring separately.
And a human needs to wake up and splash water on their face and go and read the dumps?
To a large extent, yes, right? We have dashboards that monitors all these crash dumps, catches the top hitters, but the mapping of these crash dumps to the code change being rolled out and the deployment that it maps to, because we have multiple deployments going on all the time, right? So being able to match the exact deployment, exact versions, and exact code change, that's what that repair item is about. And we made significant progress in there. In this particular case, we could clearly map it back, right? But this is like a work in progress sometimes, right? You have to keep improving that system and signaling around it.
So we spoke about the lowering the thresholds, and we spoke about correlating them to deployments. And I know we don't want to add a bunch of stop signs to our deployments because they need to go. We need to keep customers secure and deploy things. But really, one of the more interesting pieces for me was the long-term re-architecting of our VTPMs. Is that something that Microsoft does, or is it in tandem with our vendors? I'd love to know about what are the thoughts here around re-architecting or changing the architecture or the behavior of our VTPMs?
Yes. So the TPM itself is actually a standardized interface and device. And so there's actually, you can go out online and you can look it up. There's a consortium that actually publishes a specification. And the TPM module, we have a reference code that Microsoft actually provides. And we leverage that reference code for our virtual TPM. And there are industry, silicon providers out there that leverage that reference code to actually implement, physical TPMs. And so, from that perspective, our virtual TPM is still going to continue to be based on, this reference code because it is an industry standard. What we are looking at doing is improving some of the aspects around the virtual TPM implementation to improve, our resiliency in cases where there could be, issues like this. And in particular, the issue here around the fact that there was a persistent issue because the virtual TPM has this persistent state that is necessary to provide the features of the virtual TPM or any TPM. It has to store state that is persist across VM boots. But we are looking at ways that in the event that that persistent state were to have an issue in the future, there are ways that we can, more easily mitigate that without requiring, fully disabling TPM. Perhaps, being able to reinitialize the virtual TPM, both either, automatically or having the customer be able to do it. And so we're, investigating some different possibilities there.
I know that one had a longer ETA, so that's definitely a long-term kind of improvement here.
That's right.
Lastly, on our repairs, one of the questions we get from customers a lot is around testing. Hey, what do you mean this bug made it through testing? Well, we had a throwaway comment in the post-incident review saying that we're going to expand our automated test coverage. Can you talk us through a little bit about how we'll try to catch this thing before impacting production, given that gray failure of not really happening quickly?
So. We do have a lot of testing. We have testing that's closer to the developer checking in the code, so inner loop testing, branch regression testing, outer loop testing, that are long haul testing that goes and test things for longer periods of time, stress, perf, all those things before anything rolls out. All these things happen before anything rolls out. There were clearly gaps in here. We were not exercising the VTPM the right way to get it to the state, and also closing the persistent TPM state. So those are the new gaps that we added to the tests, and we've added it in different rings. I think that will get us, this problem would be caught definitely, and similar problems on this scale would be caught in this process.
So we speak to our customers about reliability being a shared responsibility. And so a lot of the time we say to customers, hey, if you're going to have your mission control, can't fail solutions in the cloud, you need to make sure that there's some sort of high availability or some sort of added protection. Was there anything customers could have done in this case to be resilient to this type of failure?
Yeah, I think in this particular case, the best thing customers could have done is, had their services set up to spread across multiple zones and multiple regions. That is the best, mitigation in this particular case, just because of the fact that, when a deployment like this happens that introduces an issue, that deployment ultimately, can be contained to some subset of regions, and therefore, may only impact a subset of the customer's, virtual machines. But I think, otherwise, the customer having backups and the ability to, potentially roll back could have been I know some customers mitigated, I think, in that case by simply either, deleting the VM and creating a new VM and attaching their storage to the new VM. Those are things customers, having a playbook for something like that, a customer could have done. But, certainly we take it as, understanding that we need to do better here so that, customers don't have to have, those kinds of things. But those are things that, a customer may want to have just in case.
Those are good best practices. Even though this was multi-region, it might have de-risked customers a little bit. And another kind of point in the perspective of treating IT services as cattle, not pets, to be able to blow it away and create a new one.
Right, exactly.
That's really helpful. Thank you for explaining those different elements. We've got a few minutes left here, and I've saved my last question for my co-host Sammy. Sammy runs our incident comms team. So we like to take a breath and have a look at how did we do in terms of informing customers? This is a long outage. Did we keep customers apprised?
So we did. The first communication came out about 5 days after the potential impact started, and we spoke about the detection and why this was a problem. And this incident also had a kind of growing impact, and it wasn't static. We had two main comm streams where we had customers who were impacted, and we said, hey, this is something you should you need to be mindful of. And then there was a potential impacted customers to say, hey, we are having this issue. It's with V6 TPMs, and so we tried to give advance warning to those customers to say, hey, you might be running into this problem. After about 24 hours into this, we were able to, within 24 hours, we were able to provide a workaround. Initially, it was very kind of, hey, go into here, toggle this setting for your virtual machine. After a while, particularly when we think about scale, we gave customers programmatic advice saying, hey, if you want to use PowerShell, if you have a fleet of virtual machines you need to update, here's the way to do it. We did that pretty quickly because we realized onesie twosie didn't work. After about 24 hours, the engineering team got to a place where new virtual machines were not going to start up with this issue. And that was an intended workaround that David alluded to say, hey, if customers need to get back up and running, create a new virtual machine, we've stopped the bleeding, you can attach your stores there. And so as they mitigated, we kind of gave these updates about how we're mitigating in phases. We did speak around the hot fix that we were testing, which was to disable the VT APMs for impacted customers. And again, we kind of on the 14th at around, we said this was going to be completed by 2300 UTC on the 14th. We got it completed by 2200 UTC on the 14th. And then we told customers, hey, we should be mitigated by 0400 UTC on the 14th. We were mitigated, I think, about 30 minutes before that. And so for all the customers that we said, hey, potentially this could be a you problem, we said, hey, you weren't impacted, everything was fine. And again, we told customers as well, listen, you need to go and re-enable this VTPM. So if customers are listening, just to emphasize that point, you need to re-enable the VTPM and then do the reboot as well. Overall, it was great that we could provide ETAs where we had them. Like a lot of the stuff, it's very complicated to get ETAs because we want to give customers all the information that we know. And one of the things just to reemphasize is we don't tell customers what to do. We want to arm them with enough information so they can make decisions. Customers have different thresholds for pain, and so we want to make sure that we did that. I think some of the areas we could have done well is when we talk about we're developing mitigation strategies, we should have been more open and more transparent. But I like the idea that immediately we could provide workarounds and wherever it could be provided ETA. So not perfect. We still have work to do, but yeah.
Still got some learnings, but at least the cloud wasn't a black box, and we could try to explain what was happening to impacted customers. So thank you for watching this Azure Incident Retrospective.
At the scale of which our cloud operates at, incidents are inevitable.
Just as Microsoft is always learning and improving, we hope our customers and partners can learn from these too, and provide a lot of reliability guidance through the Azure well-architected framework.
To ensure that you get posted incident reviews after an outage and invites to join these live stream Q&A sessions, please ensure that you have Azure Service Health Alerts set up.
We really focused on being as transparent as possible and showing up and being accountable after these major incidents.
Whether it's an outage, a security, or a privacy event, Microsoft is investing heavily in these events to ensure that we earn, maintain, and at times rebuild your trust. Thanks for joining us.